Okay,
And
now
no, I cannot answer about this picture.
it's an obvious picture anyway. Okay, now time for without even asking, then go ahead.
Thank you. I'm wondering, have you considered using this method for time multiplexing for different time zones? So, because maybe the power is not the most expensive here, but the other beacon or everything, instead of shooting it down, you put it on in, maybe it could be more useful.
Yeah. So the question being, have you considered strategies where do you place the workload? Maybe in a data center that's more power efficient, or the data center where the power consumption costs less? These are the so-called follow me or follow the sun scenario, where we move each workload along with usage. Maybe the office in China is waking up, move the relevant workloads closer. We haven't looked at this scenario. We have thought about this because follow the sun systems have been, the concept is not a new one. We are going to look at efficiency of different power of different data centers based on the first case. So in the first case, we're looking at historical data, not using the predictive data. We are going to look into this in order to give them some meaningful estimations of if you turn it on, if you turn 10 of your servers off, you would save X. So for that X, we need to do that calculations. But yeah, that's a good question.
Okay, other questions? I know that you probably have one, and as soon as I start closing, yes.
Hi. How often do you train your models?
How often? Yeah, let's give the question to whoever is training the models.
Okay. So we are.
That's Pavel, by the way.
I'm the guy who is responsible for the models. So the model is trained every 15 minutes with the data for the last 12 hours. If it's enough.
Good. Okay. Other questions? Okay, this was by the way good. Other questions? Questions? Criticisms? Or not remarks or whatever? Yeah.
I just wanted to ask how many zombie machines did we find at the end? So
Yeah, zero. Zero. No, well, it depends really on your definition of zombie. So all of these machines were, even if the CPU metrics were showing zombiness, deadness, I don't know. Even if some of the metrics were showing they were not being used, it turns out they were due to some other metrics. For example, in this case, it was the disk usage, I believe. So disk usage was above the threshold for unliveliness. Okay, I don't know the term for unliveliness. Yeah, zombiness. Even though we found zero machines, we did find out that we could do all this computation probably with less machines. I don't know if they started experimenting taking the machines out of the cluster, but they should be able to do that with five to six machines. Whoever made it.
Okay, other questions?
Fun story about that. So one of those local legends was that the initial creator of the method for finding zombie machines was, I don't know, a senior director or VP. I'm saying it's an urban legend in the company that one day he would just randomly unplug certain servers to see if anyone would complain. So that's one way of discovering. I don't know if it's in this company or another, but That's one way of discovering if a machine is being used.
Not very data based.
But it's not
approach.
data driven. It's not for us.
Not a data driven approach.
It's not very scientific.
No, it is scientific.
It's stochastic.
Yeah, it is. Yes. It is in a very root level. It's scientific. Anyway, other questions?
I'll be around. So
Actually, I have a question to you. Since you already mentioned several of my favorite terms, if you have, you call it black swan event, if you have an extreme event, whatsoever we want to call it, this means that you have to have some sort of insurance, which means more computers connected to the cluster, just for the sake of this statistically rare event. So basically the prediction model would work fine in most cases, but then again at peak levels you're going to end up with sharp. Right? So what would you propose to do in this case?
well, in this case, we could probably exclude. We thought about that. So in this case, we'll probably exclude some of the servers from the computation. We'll probably have the spare capacity for just in case.
Reserve. Okay, other questions? I didn't see if this was a hand or a beer, but this was a beer, okay. Okay, go ahead.
You mentioned a lot of data points. How many in terms of how big was the data set?
50 million? Something like that. Oh, it's 16 machines, well, 16 now, it's 86 machines, generating 25 machines each, 20 seconds per each entity. I would say, I think we logged a bug at around something like 50 million data points daily when the system would be processing. Or the system ran essentially.
Other questions?
No.
Other questions? 3, 2, 1. Okay, then I would like to thank Veselin again for the wonderful talk and the interesting cases. And of course, you know where we are going from there. Actually, we are going to have an informal question and answering right now. Help yourself with the food counter back there and drink as much beer as you can take from VMware. We would like once again thank them for hosting this event, and let's close it. Thank you.